There were some brothers who owned a bunch of timber and they ran a logging company in Central California around the turn of the last century. And their mother, Nicene Marks, was a wonderful woman who loved to spend time in the outdoors. She loved the trees and the plants. And so when she passed away, her sons took 8,000 acres of their property and dedicated it to be preserved, and it became known as the Forest of Nicene Marks, and eventually it became a state park. Now, if you're a logger or a biologist, you're going to have different reasons, but you're going to have an interest in knowing how many trees are actually in this forest, or in any forest. And so here's how we can do that. We know that we've got about 8,000 acres of redwood forest. Actually, the whole park area is more like 9,000 acres, but about 8,000 of them are covered with redwoods. And now we do something. We take a sample, and it would take too long to actually go through the forest and count every single tree for all 8,000 acres. So we pick a few patches, and just to make things simple, let's assume that each of these squares represents 1 acre, and that this green rectangle is the entire forest or the entire park. At this point, we just pick a small area, and we count the number of trees in that area, and then we take an average. In this case, we've got 1, 2, 3, 4, 5, 6, 7 different plots. So we count the number of trees on each plot, add them up, and divide the number we get by 7, and this gives us an average. And it's going to turn out to be around 21. So now we know there's an average of about 21 trees per acre, and there are 8,000 acres. So we just do a little bit of math here. 21 times 8,000, and we know that there are about 168,000 trees in the Nicene Marks State Park. This works fine when you're talking about trees, but what happens if you want to measure the number of the population size of some kind of animal that moves around, or birds? Well, there's a way to do that too, and we call this technique the mark and recapture method. First, we capture a bunch of the individuals that we want to count, and we tag them. And this means if you got sometimes when we capture birds, we'll tag them by putting a bright colored plastic band around their leg. I've seen people capture black widow spiders in a cave and actually paint a number on their back with a permanent marker. So anyway, you do something to indicate that this animal has been captured before. Then you release it back into the wild, and you repeat the process, and the second process yields some interesting information. Now, since we are capturing the same species, and it's in the same area from the same population, it's possible to capture the same animal twice. And you'll know if you did this because when you capture it the second time, it will already be tagged. And as you can see from this diagram, this information can give you some clues about the size of the population. If we've got a very large, dense population here, and let's say the first time around we tagged 5 individuals, and now we're going to go back and capture more, you can see that it's possible that the second time around we might capture 1 or 2 of the same individuals again. It's not likely we would capture all 5. However, imagine we're looking at a population that's much smaller, and the first time we captured and tagged 5 individuals, and the second time around, the odds of finding more individuals that have already been tagged are much higher. So this tells you that the second time around, if a lot of the animals you capture have already been tagged from the first time, you know you're dealing with a fairly small population. If very few of them are tagged the second time around, then you know the population is larger. And then you do a little bit of math to get a good estimate. So we've seen that the number of animals that are already tagged in your second round of capture can tell you something about the size of the total population. Let's see how this works. We'll just say that the total number of animals captured the second time around is the letter N. And out of those animals, the number that have already been tagged is the letter X. So that gives us a formula, X over N, and that equals the number of animals captured the first time around divided by the total population. So we see there's a ratio. The number of animals that have already been tagged divided by the number that we catch the next time is assumed to be a similar ratio to the total number of animals divided by the total population. And now we say that total number of animals captured the first time is letter S. And remember, the ones we catch the second time that are already tagged is the number X. And we say the total population is going to be the capital letter N. So now we have this reduced to a simple mathematical formula. X over N equals S over N, where X is the animals we caught the second time around that are tagged, and N is the total number we captured the second time around. S is the total number of animals we captured the first time around, and the capital N is the total number of individuals in that population. So now we can plug in some of these numbers and figure out how many individuals we're dealing with here. First, we'll manipulate the algebra a little bit so that we can get a simple number n on one side of the equation. So now we know that s times n, lowercase, divided by x equals the total population. Now let's do the math. So going back to that diagram, the first time we captured and tagged 5 animals, so s equals 5. The next time we went back and captured 5 animals again, and one of them was already tagged. So now we have x equals 1, because that's the number of animals that were already tagged. N equals 5, because we went back and captured 5 animals the second time. And we already know that s equals 5, because the first time around we captured 5 individuals. So now we can plug the numbers into the equation and find out how many individuals are in this population. Capital N equals s times lower n divided by x. We know that s equals 5, lowercase n equals 5, and x equals 1. So we have 5 times 5 divided by 1, and that gives us 25. So we can assume there are 25 individuals in this population.